All right, hey everyone, welcome to our midweek thing here. Not really midweek, it's Thursday, but you get the gist of it. We're going to round off our relations and functions unit, and we're just going to talk about applications of linear functions. And yes, fortunately, that does include doing word problems. So algebra word problems to be precise. I found a GIF on actually reflects that. Okay, so I just need to do a brief note on algebra, which I took for granted in the last lesson because I was assuming that you had probably a bit more knowledge than you actually do with respect to solving algebra questions and different relations. So I'm just going to talk about that just before we dig into the last part of this lesson. So just a brief note on what it means when we're actually looking at a linear function. Most commonly, the most common form a linear function is in, form of a linear function, and you might remember this from grade 9, is our slope-intercept form, sometimes what it's called, or y equals mx plus b. Y equals mx plus b. I'm not too like bent on actually you knowing this and memorizing that. I am more intent on recognize that when we're trying to solve for a linear relation, or when we're trying to simplify a linear relation, it's best to get it in the form where y is on its own and we have whatever is left on the other side as just what it is. So let's say that we had 5x plus 1 on that side. This is the kind of desired form we want. So we could say desired form. And the reason that this is desired is because we could say that this part kind of represents the function part, or the part that is in our function machine. This is our output, and then our x here is this is our input that we did. So when we have that function machine over here, and we said that we plug an x into here, this is where it does the work, 5x plus 1, and then out we get our y. It's essentially the same thing. So the goal when we're trying to solve for a linear function is to always try and get y on its own. So I'll write that just as a note here. Always try to get y on its own. Y on its own. And just the brief note on the homework that I was seeing with some folks who submitted their things, if we have something that was like x minus y equals -6, and I told you to figure out what the y-intercept is. So remember, if we're finding the y-intercept, we set x equal to 0. Find y-intercept. We set x equal to 0. So what most people did, they did this, they put in brackets and they subbed in that 0. But then what I saw was happening was then they would just go y equals -6. So this is, you're not wrong. I'm not going to say that you're wrong. And there's a different way that we can go about thinking about this. What you're doing is correct. The general idea that you have in your mind is correct when you're dealing with something with this. But the problem is that we're just not accounting for that negative sign there that's hanging out in front of our y. So if we take into that into account, well, what we get now is -y equals -6. And generally, when we're solving algebra questions, we don't want to leave our variables negative. We don't want to leave our variables negative. We want to leave them positive because that's usually the most common form that we see them in equations when we need to sub something back in. We don't want to leave our variables negative. So what can we do to get that negative out of the y? Well, what we can do is you can do one of two things. You can either multiply everything by 1. So you can either multiply. So this is your first one of attack, multiply both sides by -1, or divide both sides by -1. One or two options there. It doesn't matter which one you do. So if we do that, we bring it down over here. Well, we have -y equals -6. I'm going to do the divide because that's what I'm most used to doing. We're going to divide both sides by -1. And what we get is positive y, because anything divided by 1 is just itself. And instead of -6, since we're dividing by -1, we're getting a +6. And that's what we get for y. Okay. So just a really brief note on that. The knowledge that I am expecting you to still have enough where I don't need to go through the basics of algebra is just this idea of putting things on either side of the equation and then doing what you need to balance everything out. So let's say that we wanted to move this -y to this side. Well, we know you should have learned from grade 9 that, hey, if we need to do that, then we're going to do a +y on this side and a plus y over here. And we're doing the same thing on both sides, but the plus y and the minus y will cancel over here. So just that kind of assumed knowledge that you have. Okay, so let's actually get into the gist of the material here. And we're moving into word problems. And word problems, from what I'm going to give you, I want to try and give you a better experience of word problems so that they aren't too crazy. This first word problem is going to be, it's one from the textbook. It's an example of something that I don't want to do a lot on quizzes. I'm going to show you one that I have reworked and redone after. And I'm going to, if you want to input and say which one you liked more, go for it. But we'll see. So this is your standard word problem that you're going to see over and over again, right? So the given cost, C in dollars, of renting a hall for a dance is given by the formula. And it's usually good when you're going through these type of word problems to underline any formula that it gives you. So we have this formula right here. C equals 4n, 4 times n plus 100, where n is the number of people in attendance. The hall can hold a maximum of 500 people. So usually with these ones, you'll have them in two parts. One will ask how to calculate just the output of whatever the function is. In this case, wants to calculate the cost. And then the second part will be trying to figure out what n is for a certain cost. You'll see what I mean here. So for this first one, calculate the cost of 327 people attending the hall. Well, where all you're doing here is a plug and play. Plug and play. I'm really not a fan of these questions, but I want to give you the exposure to give you kind of like a A/B test here to see which ones you actually enjoy doing more. This is a plug and play. So we basically see that we want to put in 327 people. And remember, our people is also equal to our n, right? Look back up here, n was referring to our people. So we're going to be plugging in 327 for n. So let's do that. We're going to write out our equation. C equals 4 times n plus, is it 400? 100. Okay. C, now I'm going to plug in my 327, 4, and I'm going to write my brackets, 3, 2, 7, plus 100. C equals, and this is literally just doing bed mass in the right order. So what's 4 times 327? Well, that is 1,308 plus 100. C equals 1,408. Okay, and you don't just stop here for word problems. What I do want you to do is to communicate what that number means. So what we can say is we'll put a therefore sign. Therefore is just those 3 dots, by the way. Therefore, if we have 327 people, the venue will cost $1,408. Okay, that's all you would need. That is all you would need to put for a question like this. Okay. All right, let's go into B here. If it costs $896 to rent at the hall, how many people were in attendance? So same kind of idea, right? Instead of solving for C in this case, we're solving for how many people are in attendance. So let's rewrite our equation. So we have C. So remember, this equals C. C equals 4n plus 100. Okay. Well, our cost in this case was $896. So we're going to sub that in. You could do a decimal there if you want. It's one whole number. You don't have to. 4n plus 100. So now you have to use a little bit of algebra to solve this, right? And the question that we're going to ask ourselves is, what's the easiest thing that we can move right now to get 4n on its own? What's the easiest thing that we can move to start to get this on its own? Well, we could move this 100, right? What if we just subtracted 100 from both sides? Minus 100, minus 100. Well, what we get is, on this side, we get 796 equals 4n. Okay, so we're almost there. How do we get 4n on its own? Or how do we get n on its own now? So remember, 4 is multiplying against that n. If there's nothing written here, 4 is being multiplied by n. Well, we're going to divide by n if that's the case. We're also going to divide by 4 to get n on its own. We're going to do it on both sides so that things stay equal. That's the whole thing of algebra. If you do something to one side, you have to do it to the other to keep it balanced. So we ask ourselves, what's 796 divided by 4? I'll plug it in my calculator. So it's 199 equals n. Okay. So again, we'll finish this off with a word, and we'll say that therefore, for a cost of, and it's usually best to include both values when you're doing a written response. For a cost of $896, 199 people were in attendance. And there's going to be like a big array in terms of what word problems will sound like. this is the way that I'm wording this one. You could word this in a completely different way. It's just up to you. As long as you're communicating what the question is essentially asking, and you're doing that in a clear way, using and supporting your answer with numbers, you're a-okay for solving anything like this. Okay. So example 2, this is going to be a little bit different, or hopefully drastically different, from the type of question that we see up here. And this one is going to use me as an example. So Mr. Carroll, he fills his tank in his CRV at the beginning of the week to its capacity of 80 liters. Okay. Over the course of the week, as he drives around Abbotsford, his fuel decreases linearly until he breaks down on Highway 1 after traveling 500 kilometers in total. And he breaks down because he's lost fuel. We can say that he's broken down because he's lost all his fuel. Okay. Describe Mr. Carroll's function on a graph of, so it's function of basically driving on a graph of volume of gas in liters versus distance. So let's see how we can do this. What I'm going to do, I'm going to set up my graph first. The way I'm going to do this is I'm not going to put it in the center, because all the values that I'm writing on this graph, they're going to be positive. We're not going to really have a negative distance, right? And we're not going to have a negative fuel amount. So I'm going to draw, oh my gosh, draw something like this. And we'll say this is my y, this is my x. And what did we say that we wanted to label this graph as? So we wanted to label it as volume of gas versus distance. So typically when it's written like this is referring to the whatever the first measurement is. This is going to be your y-axis, and this is your x-axis. Another way that we can define these is our y-axis is also known as our dependent variable, and our x-axis is known as our independent variable. So dependent variables are usually things like distance, cash, etc. And independent variables are things like time. Time is a big one. Sorry, not distance. Volume, time, distance, etc. Okay, so let's label those axes really quick. So we have volume here, volume of gas. Whenever you write something on an axis, make sure that you underline it with a straight line and put in the units that it's being measured in. So we have volume of gas, liters. Let me underline that. And then on our x-axis, we have, what do we have? Distance. Distance in kilometers, right? Beautiful. Here's that. You could put a title on this if you want. I'm not going to do that just because I was a goof and forgot about my spacing here. Okay, so let's see, how do we actually graph this? How do we graph this? Let's look at our question again, or the scenario. Mr. Carroll, he fills his tank in a CRV at the beginning of the week to its capacity of 80 liters. So we can assume, let's assume that Mr. Carroll, he hasn't driven anywhere once the tank is filled. So where on our graph in terms of distance would we plot that 80 liters mark? Well, we plot it at the zero distance, right? That's where we're going to assume that his trip, or that we're measuring his distance right after he fills his car. So let's put some marks on here to measure out what 80 meters would look like. Now, it looks like if I can, let's try doing every other one. 10, 20, 30, 40, 50, 60, 70, 80. Perfect. So here on the 80 mark, I'm going to fill in, oops. Oh, come on. Wow. Sorry, folks. Here we go. So here's our 10, 20, 30, 40, 50, 60, 70, 80. Okay. And when does he run out of fuel? Because that's going to be another major point on our graph too, right? When does he run out of fuel? Well, he runs out after traveling 500 kilometers in total. So we have that. We can mark that on this graph here. We just need to make a scale for it. So let's think about what can we make the scale here. Well, we could probably do the same thing. Let's just do 100 kilometers here to, let's make them bigger. Let's do every fourth one. 1, 2, 3. Nope, that won't work. Let's do every third one. You know what? Let's just do actually every second one, just to keep things nice and simple. 4, 5, 6, 7. So this is 100, 200, 300, 400, 500, 600, and 700, right? Good. And let's mark on there that 500 mark, because this is where we run out of gas, right? So it makes sense that our volume of gas here is at 0 at the 500 kilometer mark, right? So we're just thinking about this logically, about where things would fit on this graph. And what do we need to do now? We have 2 points. How can we do something with those? Well, the big key thing here is that we see that it decreases linearly. It decreases linearly. So we know that we're going to have a straight line between 800 to 500. Beautiful. So there's our graph. There's our graph. It's a linear graph that has 2 points, and we've colored those in. So we started at 80 kilometers in total, and we ended at 500 kilometers. Sorry, 80 liters in total. We ended at 0 liters and 500 kilometers. So let's go look to see what else this question is asking. Write the coordinates of the x-intercept and y-intercept, and we need to figure out what those represent. Okay, well, let's start with the y-intercept, just because I want to. We see the y-intercept occurs at, when does y-intercept occur? When x is 0, so 0, 80. 0, 80. Y-intercept equals 0, 80. Let's do the x before we explain these. X-intercept. What's the x going to be? Well, the x is when y is equal to 0. So 500, 0. Remember, our x term comes first in our ordered pairs. 500, 0. What does the y-intercept mean? What does it mean? What were we talking about when we plotted this? Y was when I first filled up my tank. Represents when Mr. Carroll first filled his tank. Okay. He hadn't driven anywhere until he filled his tank, except maybe to the gas station. I doesn't count though. X-intercept, what does the x-intercept represent? Well, in this case, x-intercept represents, what do you think it means? You can pause the video and take a guess. Well, it's the maximum distance that I went on 80 liters of fuel, right? Because I ran out of fuel right there. That's when our fuel line went all the way down to 0 liters. So that's the maximum distance I went on 80 liters of fuel. Max distance on 80 liters of fuel. I went 500 kilometers, right? So that's what those two represent. This will be something I for sure ask you on a question for a quiz or a test. And C, as Mr. Carroll drove each day, he lost some fuel in his tank. What is the rate at which he lost fuel? What is the rate at which he lost fuel? In other words, well, I'm going to ask you a question right now. Let's say that I started at 80 liters. Let's say that I started at 80 liters, and instead of dropping out at 500, I dropped out at 700. The question I'm going to ask you is, which of these two lines did I lose more? Did I lose fuel faster at? Which of these two lines does it look like I lost more fuel at? Well, you might, with your intuition, you might be saying, well, hey, the steeper line looks like you lost fuel a lot quicker than the red line here, where you lost it at a slower rate, right? So wait, well, what about this one? What if instead this was my drive? I went from 80 liters all the way down to 100, all the way down to 0, and only drove 100 kilometers. Which one here, the pink, the blue, or the red, is going to be the one that looks like the faster rate loss? Well, this one, right? Because it's a steeper one. We can kind of feel that this is the faster one just based on our intuition. The steeper the slope is, or the steeper the line is, the steeper the change is, right? The steeper the change is. So I'm going to erase those two, and let's go back to our original question. We need to figure out what the rate of change for this line is, or essentially between we can ask ourselves, how much fuel is he losing from each box to the next? From each box to the next, how much fuel is he losing from each box to the next? And we can do this kind of many different ways, but the way I'm going to show you is essentially, let's find 2 points on this graph that line up really well with between the boxes. So looking at this right now, I can see that this point right here, actually, we'll make this an actual circle. Oh no. This point right here matches up really well. And let's label this point actually. So but this point is called, what is this? Let's figure out which. Oh my gosh. Come on. There we go. Move that back down. So this is point, let's look on our X first. It's going right there. So this is 250. and 250, 250 and 40, right? That's how we would measure that, 250. I'm just going to separate this. And then let's find another point that matches up really well in that graph. Well, it doesn't look like anything really is perfect, but what we can do, we can use one of those 2 points that we drew over here, right? So I'm just going to use, just for the sake of being nice, let's use this point right down here. And let's see if I can, perfect. And this point is, let's see what this point is. Well, this was, we said it was the x-intercept, so this was our 500, 0. And essentially what we're going to do to figure out what the rate of change is, I hate when it switches the eraser when I don't want it to. We can think of the change of, or the difference in the rate of change. Let's pretend that we were measuring what was the difference between going from 0 kilometers to 50 kilometers? How much did our fuel drop? So we're measuring essentially how much did we drop in our y-axis between here and there. So what we can do instead is we can, I'm going to draw this kind of triangle looking figure right here. Okay. Well, what we can do, we can measure how much we changed or how much distance there is between this 250 mark, so 250 and 500 meters. So we can measure, because essentially all we're figuring out with this rate here, so our rate, we're trying to figure out how much liters per kilometer, we're using throughout the course of our trip, or what's the rate of our liters per kilometer here. So we're taking the amount of liters and we're dividing about the amount of kilometers. And the reason that we're choosing 2 nice points on here is just for the sake that it makes our lives easier if we could find 2 points that we can do this division with. So let's look at we said our kilometers. What did we say our kilometers were? We said our kilometers were going to be, because if we're measuring the change between these 2 points, we need to figure out, well, how many kilometers are there between this point and this point? So the way to do that is we're going to ask ourselves, what's 500? What's 500 minus 250? What's 500 minus 250? Okay. And then the other one, we might be saying, well, where's the y coordinate? We need to figure out, well, how many liters we're losing in between that time. Well, how many liters are we losing? Well, we're ending off with 0 liters, right? We're ending off with 0 liters. And how much did we have over here? Well, we had 40 liters. We had 40 liters. So 0 liters minus 40 liters. And we do this. What we see is with 0 minus 40 is just negative 40. 500 minus 250 is just, 250. What are we left with? Well, what's 40 divided by 250? That is negative 0.1616. And what was our unit again for a rate? It was liters per kilometer. Liters per kilometer. And that is our rate. That's how much fuel we were using essentially. And cars do this on the dashboard. If you got one of the newer cars, it will actually calculate your fuel economy. And in this case, it doesn't usually calculate it in liters per kilometer. I think it's 100 kilometers per liter. But the same idea here, it's basically doing this calculation based on your driving. If you drive aggressive, you're going to have a really crappy mileage, right? But if you drive smartly and use your fuel wisely, you're going to have a good mileage. And basically, this is saying that we're using 0.16 liters per kilometer that we drive. So let's go back to the question. So according to the graph, we use 0.16 liters per kilometer. And the general formula for that is you're going to find 2 points. So you're going to have 2 points. So find 2 nice points. And the first one that you find, or the one that comes first in the graph. So in this case, if we're reading a graph from left to right, this one's coming first. The one that comes first, I'm just going to call it just a blanket coordinate. It'll have a coordinate of x1, y1. And your second one, or the second one that we found, which was this one down here, it was going to have a general coordinate of x2, y2. Okay. So our x1, y1 this was our x1, this was our y1. Down here, this was our x2, this was our y2. And what you're going to do is to find essentially the slope. So slope equals y2 minus y1 over x2 minus x1. So you will need to know that one. And what is the main range of the function that we drew? So all I'm going to do here is just, well, let's see. I'm just going to do this and let's do it in set notation. So really quick, we'll see, say our domain equals, for fancy brackets, that x is an element of the reals, such that, and where does x lie for this graph? Well, it starts here at 0 technically, right? Because this is 0 on our x, and it goes all the way to 500. It includes 500. So we could say that x is bigger than or equal to 0, but less than or equal to 500. And our range was, let's do the same thing, y is an element of the reals, such that, and again, y, it had to be bigger than or equal to 0, right? Because it started at 0 down here and it went all the way up to 80. It has to be less than or equal to 80. So that's kind of the general idea that I'll give you for the questions on here. Please refer to the homework assignment, and that's really going to be the only true homework that you'll have this week. I'm going to release a quiz tomorrow based on everything up to Tuesday's lecture. Yeah, and that's it, folks. So this will be the last time you hear me this week, so I hope you have a wonderful weekend and your classes are going really well. Please shoot me a message if you're having a hard time keeping up with any of this. Alrighty, take care, everyone. Boom, boom.